Hey everyone, welcome back to my channel. Hope you all are doing great. So in this playlist I am starting a brand new React series where I'll go from very basic to advanced level of React, where we'll see what exactly the React is. It's each and every component step by step, and then we'll see how this vector database work, different kind of framework, LangChain, LangGraph for agentic AI, how tools we can integrate with the agent, what exactly the agent is, and how can we use our custom data in order to create a chatbot. This is like normal basic we'll create, then we'll go for the advanced. In advanced, what we will see, we'll see how can we improve the RAG accuracy. Like normal, if you will take the data and do the embedding, chunking and retrieval, then it will give you the result. But how can we improve the accuracy? What all the approach we should follow so that our RAG should give the better result, and how can we perform like better search. How can we do like different type of retrieval, different type of search, so that we should use that particular React system in production level. After that, we'll see how this LangGraph, different kind of agentic framework works. Then we'll go step by step. If you are totally new to this generative AI, or don't know anything about how to start, where to start, so don't worry, I'll make step by step video so that you will understand what exactly and how we can implement by ourselves. And I'll show you the architecture, what exactly, and I'll try to explain in very simple way so that you will understand it. So let's start our first video. What exactly the RAG is, let me take you through my screen and I'll explain you step by step each and every component of it. So thank you. So in next video we'll see how can we implement this basic RAG using LangChain. So we'll see how can we create a simple LangChain code in order to implement this RAG using our custom data. Then after that we'll make it in better way, and different type of approach we'll follow, and we'll see. So hope so if you have not subscribed my channel, please subscribe my channel, so that whenever I'll upload any kind of video in this area or in this topic, you should get notification. And if you want to share with your friends or anyone, you can share it, and make sure you like my video. See you in next video. Thank you, bye. Okay, so now let's see what exactly the retrieval augmented generation is and why we are using this. So basically this is our RAG, which everyone is talking about. Okay, so now before going deep into this RAG, let's understand why we are learning this. We have already a LLM in market, like ChatGPT, GPT, Gemini, Cloudy. Okay, then why we are again studying this RAG, and why we are using RAG so much in this industry? 70 to 80% of use case currently in generative AI only this RAG. What exactly this RAG is and how it's giving the benefit. Before that, let's understand little bit about LLM and what is the what are the limitation of this LLM, so that we are learning this RAG. First thing is, LLMs are trained on huge amount of data, like the public data, not any private data. Public data in the sense like GitHub, okay, then Wikipedia, and any public like Google, all the source, okay, and books, everything whatever publicly available, it's trained on that data only. It does not have access to any private data. First thing is trained on a huge amount of data. And if you have not if you don't know about what exactly the transformer, how it works, how these models are trained on, and its architecture, then comment and I will create a separate video what exactly it is, and how our traditional transformer works and something about NLP. So I think right now, just to start a RAG or a generative AI, like no need to go in depth of the NLP or all these things. So you can focus on this RAG and all these frameworks. Okay, so let's come to our topic. Now this is what the LLM is, and this is how we are using it. Simply we are asking some question. What it is doing? It is like checking its trend data, and it is giving you the generating the answer. Based on the trend data, it is giving the answer. Now what is the problem? Suppose I'll ask who is PM of India. So it's already have the information about the Prime Minister of India, and it will give me the answer because it's already trained on this particular data. Suppose this LLM trained on 2023. Now something happened in 2025. Now it does not have the information about this particular data. Okay, it's only the information about 2023 data or up to 2023 data. Does not have any information about 2024-25 data. That is the first problem of LLM. So if I'll ask something which happened recently yesterday, it does not have information about that. That is first limitation. Second limitation is private data. Private data. Suppose when it's trained on only on public data. It does not have any does not trained on any private data. Suppose I'll ask what is my leave policy. What is my company leave policy? So hence it does not trained on any private company data. It does not have answer about the leave policy of my company. So what it will do? It will simply say like I don't have any information, or I don't have any answer, or it will hallucinate the answer. Try to make up the answer so that like it will give something. So which I don't want. I want the straightforward answer. That is one limitation of this LLM. Okay, the third thing is now the cost. So I have suppose 5 use case on my company. They are having 5 different data set and 5 different use case. So if I go for fine tune it, you don't know about anything about like fine tune and all, you I'll start creating different video on this fine tuning, how this LoRa, Q LoRa and all works. We'll see in that time. So now if I'll go for the fine tuning this LLM, so hence lots of GPU required, and also the cost, that is also matter. So all these are the limitation of the LLM. Okay, so now how we can solve our problem? Before that, let me show you a simple example. Let me take you to the ChatGPT. I'll ask simple, what is my company leave policy? Okay, what it will say? I don't have access to your company internal policy. Could you tell me which company you work for, and optionally your country or region? Okay, this is what it is asking. If I'll ask something different about my private data, it won't give exact answer to my private data. That's the problem. Suppose if I'll ask who is PM of India. So it will search. So right now in ChatGPT it is searching the web and it is giving the answer. So it is saying Narendra Modi is the PM of India. Okay, you can see this is how it is giving the answer, but it does not have access to my private data. Now let's see how RAG is solving this problem. How RAG is solving this problem. So now what we did just now with LLM, now we have a question. What we did, we asked to LLM ChatGPT, we simply asked the question, it gave me the answer. If the answer is public, if the question is public, then answer is correct. If it is private, it is not giving the answer. Now, how we can use RAG in order to solve this problem? In RAG, what exactly happening? So instead of training the large language model, what we can do? We can use RAG in order to do kind of like in order to give the context to the LLM to generate the answer. How we can give the context? That's the RAG is helping. Okay, so how we can give the context to LLM? RAG is helping. RAG architecture is helping us. Now let's see how it's working. First is we have a document leave policy. Okay, now this is 1000 page document. What we'll do, we'll give full document to the LLM, any LLM, any Gemini, ChatGPT or anyone will give this document to the LLM and it will give me the, I'll ask some question like what is my leave policy or what is my holiday list. It will give me the answer. Okay, it will give me the answer. Now here also one problem. What is the problem? What we are doing? We are giving 1000 pages of document to the LLM. 1000 page means they are having lots of text token present in this document. Suppose we have in the 200 page we have a information about leave or holiday. Okay, in 200 and 202, 201, 202, these three places where the information present with respect to leave. Okay, now simply unnecessary we are giving 1000 pages of document to the LLM to generate the answer about leave policy. So now how we can overcome this problem? And the first thing, this is the problem of cost. If we'll give the 1000 page like so much chunk token, then the cost will be more. The input token cost, output token cost, everything will be more. So now, and also sometimes LLM will hallucinate in order to give you the leave policy. It will give the different leave policy, different answer, and it will make up some answer because it's just looking at the 1000 page of document. Now how we can do it better way? Now we have the document 1000 page. Now what we can do, we can pre-process this document. In pre-processing, we'll extract the text. Extract the text. Now after extracting the text, then what we'll do, we'll split the text or we can create chunk of this full document, like different chunking. And there is a concept called chunk size overlap. We'll see in the step by step in upcoming videos what exactly how we can do this chunking, what exactly the split, how can we define the split size, overlap size. Okay, so now we'll do extract this text from the PDF. After that we'll do splitting. When we'll do splitting, then this is first page, second page text, third page, like that, either page wise or text wise or any particular text word wise or sentence wise. There are different type of split we can do. Now we created the split. Now we have to store somewhere so that we can use this splitted document to generate our answer. Now where we can store the information. Now just imagine, suppose if we are using the SQL database, then what we can do, we can simply ask like select leave policy from the select star from the leave policy from the leave where policy equals to leave. If we'll do that, then some information will come from the SQL, but this is our unstructured data. Okay, this is our unstructured data. How we can do search in unstructured data? So for that, what we are doing, after splitting this document, we are doing embedding of each line, embedding for this, vector embedding for this. For each splitted document, we are creating a vector embedding. Okay, they are having some size. We are creating a vector embedding for each document. We created vector embedding. Now we have to store this vector embedding some database, like how we are storing the information in some SQL database structure information. For vector embedding, we can store in a vector database. Okay, so this vector database, they are having so many different type of vector database: face, ChromaDB, Pinecone, Postgres, like lots of vector database present in market. We'll see like face, Chroma, all these vector database. We'll explore and see how it's working, how we can store our embedding vector database, how we can retrieve the information. Now we store the vector database. Now we have the information present in our vector database. Now we stored. How we can use this data in order to generate our answer. Our goal is to generate our answer as per our policy, as per our private data. Now suppose a user came or an employee came, he asked some query. Okay, now query came. What we will do, we will first take this query and again we will convert this query into embedding. Okay, we'll do embedding, vector embedding of this query. Now after performing the embedding, we'll take this embedding and we'll search in this vector database. How we can do search? Using cosine similarity. Okay, using vector the cosine similarity, we can search in my vector database. Now from this vector database, we'll check the highest accuracy chunk or higher accuracy embedding chunk. What are the higher accuracy? We'll only pull out that chunk from the vector database. Suppose we define our top k size 10. What this top k size? We'll also say, discuss what exactly the top k and how we can change this top k. Top k means top 10 accuracy information will chunk will take from the vector database. Now we retrieve the top 10 document. Okay, when we did the vector similarity search, now our information present in 200 number chunk, 201 number chunk, 202 number chunk. So these 200, 202, 203 should come in my top 10. Okay, why it will come? Because my query and my query embedding and this answer embedding, the information embedding would be match. I'll get all those chunk inside my top 10 document. Okay, now after that, once I'll receive this top 10 document, now I have already a prompt. This one also we will discuss. Now only focus on how this RAG is, this architecture is, and all these component will in step by step we'll discuss and we'll see. Now we have a prompt. What exactly the prompt? In prompt, suppose we have defined this is my query this is my prompt, and this is the top 10 document. Now I'll ask to LLM, take this query and take this top 10 document which will act as a context, and this is the prompt. Answer in this particular way or in this particular format to my user. So I'll pass to the LLM. When I'll pass this information to the LLM have capability to understand the document, the context, and the prompt and the user query, and it will generate answer, and it will give pass to the employee. This is how RAG is working. This is very simple RAG. Now you might have thinking like, what exactly simple? This is also complex. No, this is like a simple architecture of RAG, but they are having so many things to make it better, which we'll discuss, like how we can better make it better, how we can do better pre-processing, how we'll select the chunk size, how we can make it better retrieval. Okay, different type of retrieval, different type of search, hybrid search, everything, re-ranking. So this is what exactly the RAG is and how it works. And in next video, what we will do, we'll go the step by step each component, how it is working, what exactly it is, what exactly the chunking is, how we can do chunking, how we can do better chunking, and we will use some different kind of framework, LangChain and all, in order to perform some query and do some coding. Hope you understood the basic of RAG architecture and what exactly and why we are using this RAG. What was the demerit of LLM, like limitation of LLM, and why we are using RAG. So in upcoming videos we will see each and every component of RAG, how we can make it better, how we can make it advanced, how we can evaluate a RAG, how can we use RAG as a tool in an agent, what exactly the agent, everything will see step by step in upcoming videos. Make sure you subscribe my channel and hit that bell icon so that you will never forget and never miss my content or my videos. See you in next video. Bye.